Okay, we have question 102. The question says, which of the following graphs represents the variation between resistance R of a variable resistor and the current I? Okay, so it's R versus I in a variable resistance if the potential difference is steady, it's a constant, it doesn't change, and the temperature is also constant, okay, at a constant temperature. Okay, we know the Ohm's law before. We know that at a constant temperature, the relation between current and potential difference is directly proportional, and it is a linear line. Okay. Here, depending on Ohm's law, I can do this table. I want you to pay attention to this table, please. It gives the relation between the potential difference, the resistance, and the current, okay, at a constant temperature. Always the temperature is constant. So when we make one of these variables constant and we study the relation between the other two, we will find. Please pay attention to this. Okay? Here, I'll change the color. Here. So, when the potential difference is constant, the R and I inversely proportional. So when you increase the resistance, there will be less current at a constant potential difference and constant temperature. So basically, I can say that resistance is proportional to the 1 by I, or I can say inversely proportional. Of course, you can say also that I with 1 by R. Okay, so these are inversely proportional. Okay, this is regarding the potential or the constant potential difference. Okay, now when the resistance is constant, I will not complete. Okay, when the resistance is constant at a constant temperature, this is Ohm's law. There will be when the potential difference increases, the current will increase. The V and I are directly proportional, so V directly proportional with I, and vice versa. I can say I directly proportional with V. This is at a constant resistance and at constant temperature. Okay? Okay. Now, when the current is constant, at a constant temperature, the V and R inversely proportional. When you increase potential difference, the resistance will decrease. So they are inversely proportional. I can say that V inversely proportional with R. Okay? Notice that I said inversely because I put 1 by R, right? And vice versa, I can say R, resistance, is inversely proportional with the potential difference. Okay? All the relations here will be linear. Okay? Because one of them is constant and also at a constant temperature. So, our question is asking about the relation between I and V, I and R, current and resistance at a constant potential difference. So we are in this case, okay, notice they are inversely proportional and it's a linear relationship. So the correct answer will be B. Okay, inversely proportional and linear relationship. Okay, I know, like maybe I explained a lot here, but I'm trying to explain everything related to this question. Maybe this you see this question in another way. Maybe they ask you about the relation between current and voltage, maybe voltage and resistance, etc., etc. Okay, I hope it's understood. If you have any question, please leave it under the video. See you.